Hey, so what do the chair you're sitting on, the water you drink, and the very air you breathe all have in common? Well, they all share a deep secret, a hidden world of tiny, invisible things. Today, we're going to uncover that secret life of stuff. Okay, to start, just picture this. You're in an elevator, totally packed in with all your friends. You can kind of wiggle, but you're not really going anywhere, right? Now, imagine you're all in a huge, empty gym. Total freedom. That feeling, that difference between being squished versus being free, that is the key to understanding literally everything around you. Believe it or not, whether you realized it or not, you just acted out the secret life of particles. That exact difference between that super crowded elevator and the wide open gym, that's the main idea behind the tiny invisible world that makes up all the stuff around us. No, really, it's true. See, everything is made of these teeny tiny things called particles. And how they're all arranged, whether they're packed in tight like an ice cube, or kind of flowing like water, or just bouncing around freely like steam. That's what makes something a solid, a liquid, or a gas. And just like your school has rules, this tiny world of particles has its own set of laws. And they are absolutely unbreakable. And once you know them, you'll pretty much unlock the secrets to how almost everything works. It's kind of cool. So here they are, the 4 fundamental rules for every single particle in the universe. First, they're incredibly, incredibly tiny. Second, they never, and I mean ever, stop moving. Third, there's always at least a little bit of space between them. And number 4, they're attracted to each other, almost like tiny little magnets. These 4 simple rules, they're the foundation for, well, everything. Okay, so let's take those rules and actually apply them. We're going to see how our elevator and gym analogy connects directly to the states of matter. From solid ice to flowing water to floating steam. So in a solid, like an ice cube, the particles are packed together super, super tightly in this neat, ordered pattern. The attraction between them is really strong, so they can't really go anywhere. They're just kind of stuck, vibrating and wiggling in place. Exactly like you in that crowded elevator. Okay. Now for a liquid, like water, the particles get a little more freedom. They're still close, but they aren't locked into place anymore. They have enough energy to just slide past one another. Think of it like being in a classroom. You're still near your friends, but you can get up and move around the room. And finally, we've got a gas, like the air we breathe. In this state, the particles have tons of energy. They've completely broken away from each other and are just zipping all over the place, bouncing off the walls and filling up whatever space they're in. This is the gym, total freedom, with loads and loads of space to move. This chart here really just puts it all together. You can see the pattern, right? As you move from solid to liquid to gas, the particles get more spread out, and their movement gets way faster and more random. It really all comes down to how much space and freedom those little particles have. So, what's the magic ingredient that lets a solid ice cube melt into water? What gives particles the power to go from that crowded elevator all the way to the open gym? The secret is one simple thing: energy. And that energy, it usually comes in the form of heat. So how does that even work? How does adding some heat make an ice cube melt into a puddle? Well, it's not magic, it's pure science. And it all comes down to something called kinetic energy. Kinetic energy is really just a fancy term for the energy of motion. It's super simple. The faster something moves, the more kinetic energy it has. And since we already know that all particles are always moving, that means all particles have some kinetic energy. And here is the crucial link. Adding heat is like giving those particles a huge energy drink. They just soak up that energy, start moving way, way faster, and their kinetic energy just shoots up. And yeah, the opposite is true too. Take heat away and you're taking their energy, causing them to slow right down. Okay, enough talk. Let's actually prove it. We're going to see this whole thing in action with a really simple experiment. And just a quick safety note, if you want to try this at home, make sure you have an adult to help you out, especially with any hot water. The setup is super easy. Just pour a little bit of water into an empty plastic bottle and then stretch a balloon really tightly over the opening. So now we've got liquid water particles and gas air particles all trapped inside that bottle. All right, time to put on your scientist hat. It's prediction time. We're about to place this bottle in some hot water, which is going to give those trapped particles a massive energy boost. What do you think is going to happen to the balloon? And what you look at that. The balloon inflates. But why?
Well, the heat gives the particles inside a ton of kinetic energy. They start moving faster and faster and faster, crashing into the sides of the bottle and pushing up, up, up into the balloon, forcing it to expand. That's the particle theory right there, in real life.
Okay, part 2. We've seen what adding heat does. So now, what do you predict will happen when we do the exact opposite and put the bottle in a bowl of ice-cold water? You got it, the balloon shrinks. The cold water just sucks the energy right out of the particles inside. They slow way down, lose their kinetic energy, and huddle closer together, which means they take up way less space. The proof is right there in the bottle. So, if there's one thing you remember from all of this, let it be this. Everything is made of tiny particles, and those particles are always, always moving. How fast they move and how much space they have is what decides if something is a solid, a liquid, or a gas. It's really that simple. So now you know the secret. The next time you see an ice cube melting on the counter, you'll know its particles are just gaining a bunch of kinetic energy. And when you smell cookies baking even from another room, those are actually cookie particles in gas form zipping through the air to find your nose. The world is full of examples. What else can you explain now that you know the secret life of stuff?